All right, so now we're doing applications of parametric equations. To think about this, which of these below is showing constant speed and which one is accelerating? Okay, this one is your constant speed, and this one is your acceleration. So here's a parametric equation given the height of a flare shot from a platform straight up. So if you draw a picture, you're on a platform and there's a person, right? And they shoot something straight up. So looking at this equation, what's the initial speed of the flare? That is going to come from this rate here. And then how tall is the platform comes from your constant or your y-intercept. So it has to be 15 feet. And then how high was this after 3 seconds? That's what you're going to use the equation for. So you can plug in 3 seconds. So negative 16 times 3 squared plus 72 times 3 plus 15, you'll get 87 feet. So that leaves us with a question, what is this? So if you've been in physics or other classes, that's gravity. And this is gravity in feet per second. So here, the height of an object thrown into the air can be modeled with this equation. So this is your gravity measured in feet. This is your initial velocity, and this is your initial elevation. So the question, why negative 16? It's just the basis for gravity. If you switched your units, like in science, you usually probably use negative 9.8, which is your meters per second squared. If you're doing feet per second squared, it's going to be negative 16. So then a general situation, if you're not necessarily on Earth, this would be your general equation. So you still have initial speed, you still have initial position, but then the A will change based on the acceleration. So like gravity is going to be negative 16, but if you're driving a car, your acceleration can be different kind of thing. So then the question is, what if you don't go straight up? So we've done this before with other things. You break it up into your horizontal and vertical components like we did with vectors. You break it up into the two chunks. So the example here. So a golf ball is hit at a 42-degree angle with an initial speed of 100 feet per second. It's hit from 15 feet above the ground on an otherwise level field. So we want to figure out when does this ball come down and hit the ground. So how you can do that is you can break this 170 up using what we did with vectors. So then if I'm going to write out this equation, our x or horizontal motion is just this. There's no gravity, there's nothing else. We're not like 5 feet to the side. So the x is just 170 cosine of 42 t. And here it's important, if you're putting this in a calculator, this is degrees, so your calculator needs to be in degrees. It's probably in radians right now because you just graph stuff, but if you're calculating this, it needs to be in degrees because your angle is in degrees. Or you can convert that to radians if you want to use radians. And then the y, we have to have our gravity. And then our initial speed in the horizontal or the vertical motion is going to be 170 sine of 42 t. Don't forget this t. That's very common that people forget to add that on. And then the last step is our initial position. So you want to add 15 onto that. Okay. So here's the next one. Suppose Chris and Linda toss a ball at the same time from the same height to each other. So they're both tossing the ball from 5 feet high, 2 different angles, and they are 78 feet apart. So here there's more than one option of how you write this, depending on where you put 0. So you can say halfway between them is 0, and then this would be positive 39 in the x and negative 39 in the x. Or you can say that this is going to be 0. So Linda's not any horizontal displacement, but then Chris is 78 away. It doesn't really matter. I'm going to go with the red just so I don't have to switch colors. But if we were to write this out, we have 45 as our speed, cosine of 44, don't forget the t, and then lambda didn't move anywhere because I'm doing the red one. If it was blue, I would do minus 39 on the end. If I do the same for Chris, you have 41 cosine of 39 t, and then Chris has to be plus 78 because he's 78 away. If I was doing the blue, it would be plus 39. And then the y, both of these need negative 16 t squared because of gravity. Their initial speeds are going to be your 45 cosine of 44, or sine of 44, sorry, t, and then plus 41 sine of 39 t. And then they're both 5 feet off the ground, so plus 5 and plus 5 for both of them. And that's it. Check Schoology for your assignment.